Good morning, students. Yes, today we will study one of the important concept in the structure of atom chapter, that is photoelectric effect. In the previous class we have studied what is black body and what is black body radiation. Okay, black body radiation, the mechanism of black body radiation as well as photoelectric effect are the two evidence for the particle nature of the light. Okay, we have studied the black body radiation and today let us study what is photoelectric effect. Okay, what do you mean by photoelectric effect? See, photo means what? Something related to the light. Okay, electric means something related to the current, electricity or electrons. Okay, photoelectric effect. Okay, yes. And now look at the diagram here. This is the experimental setup. Okay, long elongated tube is taken. Okay, which is packed, and here with inside it is exactly like a cathode ray discharge tube experiment, which is not there for your syllabus now because it is deleted. Okay, see here in the inside this tube, it vacuum chamber it is. Okay, the vacuum chamber it is. Okay, where there is nothing, no gas particles like that. Okay, and here a metal strip is kept, a metal strip, and it is the detector to detect the outcoming electrons. Okay, and these two are further connected to the battery source, and you can see here ammeter. This is used for the detection of current. Okay, if it is receiving any current, it will show the deflection. Got it? This is the experimental setup. Then what do you mean by photoelectric effect? See here, very easy it is. See, we are passing the light here. When this light hits to the metal surface, the electrons will come out. That is what we call ejection. Injection means it is something we are leaving inside. Okay, but ejection means it is opposite to that. Okay, electrons will come out. When a light of suitable frequency falls or hits the metal surface, the electrons will come out. How can we see that? We cannot see, isn't it? So, when those electrons will reach us the detector, and when those will reach us through the wire, we can see the deflection here. Okay? In the ammeter, we can see the deflection. The deflection shows that the electrons are ejecting because no any wire is connected between the detector to electrons here. Circuit is incomplete here, but even we can see the deflection in the ammeter. This indicates what? When a light falls on the metal surface, the electrons will come out from the metal surface. Okay, this is the rough understanding. Okay, but light should have the suitable frequency. That frequency is called as threshold frequency. If your light is below the threshold frequency, however intense it is, whatever may be its brightness, if we don't have the suitable frequency, there will not be ejection of electrons. Remember. Okay, and not all metals can eject the electrons when a light falls on them. Okay, where some metals like cesium, sodium, magnesium, such metals can only eject the electrons when a light of suitable frequency falls on it. Got it? Then what is the proper definition of the photoelectric effect? The phenomenon of ejection of electrons when a light of suitable frequency falls on certain metal surfaces. That's what I have written here. Okay? The phenomenon of ejection of electrons when a light of suitable frequency falls on certain metal surfaces. Be particular when you are writing the definition, because very soon you are going to attend the first unit test. Okay? In that, if you do some mistakes, like instead of writing ejection you have written injection, means the entire definition will go wrong, isn't it? So be particular. First you have to understand what you mean by photoelectric effect. The phenomenon of ejection coming out of the electrons when a light of suitable frequency falls on a certain metal surfaces. Is that clear, students? See, when the light of suitable frequency falls on this certain metal surface, the electrons are coming out, isn't it? This itself is called as a photoelectric effect. Okay, this experiment was conducted by scientist Hertz. Okay, and but regarding this, further study is done by the scientist Einstein, Albert Einstein. Okay, yes, students, we know that Albert Einstein has got the Nobel Prize. Okay, Albert Einstein means suddenly we remember theory of relativity. Okay, but he did not get the Nobel Prize for his theory of relativity, but he got the Nobel Prize for study of photoelectric effect, for the explanation of photoelectric effect. Okay, this is just for your information. Okay, now with respect to the exam, explain photoelectric effect. What are the points you should write? Okay, first you have to write, even in your notes also, first you write the definition, then you write the diagram. Need not to explain anything about this. Definition, diagram. Then results of the experiment. What all he observed during the experiment? Okay, first one what he observed is, okay, as soon as light hits on the metal surface, the electrons will get ejected like this. If the light is hitting this and it will move like this, means there is no any time lag, there is no any time consumption, there is no any time lag between the fall of light and ejection of electrons. Got it? There is no any time lag between the hitting of light and ejection of the electrons. Within no time, as soon as the light will hit and electrons will get ejected. Got it? Okay. And this is the one of the result. Got it? And he gave the formula for the kinetic energy of the ejected electrons. The kinetic energy of the ejected electrons is given by h nu is equal to h nu naught plus half me v square. Remember, this is the formula for the kinetic energy of the ejected electrons. H is what? Planck's constant. Nu is the frequency of the light, and h is again Planck's constant. Nu naught is what? Threshold frequency. What I said, the minimum frequency. Okay, me is the mass of the electrons, v is the velocity of the light. Got it? Okay, results, what you should do, there is no any, you write down, after writing this diagram, I am dictating, there is no any time lag between the hitting of light and ejection of electrons. First one. Next one, the kinetic energy of the ejected electrons is given by the formula h nu is equal to h nu naught plus half me v square. Okay, after writing this formula, you write here where h is the Planck's constant and write its value. You already know. Okay, nu is what? Frequency of light. Okay, nu naught is what? Threshold frequency. Threshold frequency. Remember this. Okay, me is what? Mass. Mass of the electron. You know its values. V is the velocity of the light. It is a nu, it is a v. Okay, hope you are getting me, students. Listen to me carefully and write neatly in the notes. Okay, write this formula and explain. Planck's constant, frequency of the light. Nu naught is a threshold frequency. Me is a mass of the electrons. V is the velocity of the light. Got it? Okay, this is the second result. Got it? Okay, then third point you write threshold frequency in the bracket nu naught. In front of that you write the minimum frequency only above which photoelectric effect can be observed. Only above which photoelectric effect can be observed. Remember, what is threshold frequency? You should be able to answer. It is the minimum frequency only above which photoelectric effect can be observed. Okay, these are the results of the experiment. Remember what is photoelectric effect and explain means you should write the definition, diagram and the results of the experiment just now what I have dictated you. Is that clear, students? Okay, this is all about the photoelectric effect. Okay, yes, for your unit test the portion completes up till this. Okay, what all we have covered? Discovery of the subatomic particles, we have left it, isn't it? And even the atomic models, it is being deleted from the syllabus now only for this year. Okay, atomic number, mass number, isotopes, isobars, okay, and characteristics of the wave, okay, numericals, problems, okay, and black body radiation, photoelectric effect. You can just concentrate on this syllabus up till this. Got it? Okay, you can get ready for the first unit test and happy Dasara to you all. Okay, thank you.